Okay, here I am again with the same toy with FNIRSI 138 Pro, and you see, when I got something in my head, I have to make it. Checking this battery, by the way, this came from a ruined Nano VNA, and I found that it have a BMS and a charging circuit here. So I really don't have to care about charging this battery, because anyway, it's got anything I need. All I have to do is to plug it in. By the way, now I'm gonna take a look very nice and clear to this oscilloscope. Let's have a closer look to the components, and so you can have an idea about what kind of circuits are there. That is my microscope. Let's start from this corner. We have the BNC connector right here. Okay, this is the new battery connector. I just plug it in. Then we have the USB-C connector. Here is the missing circuit. I don't know really what it have to do, but I think it's for charging the battery or controlling the battery. Here is a coil missing, and a diode, and probably a resistor or two. I don't have the other model, you know, with the battery on. The power switch. We have an electrolytic there. Okay, let's go up again. Nothing special here. We have a, what kind of circuit is this one? Oh, that's the relay. Yeah, I heard that before. Nice. Yeah. Okay, so that's the circuit I've been trying to identify near the BNC connector. So this is a Cosmo I214S G12. Okay, this is one of the circuits. So now the BNC, it's down here. I think this is the main processor. What we got here? S#39F103C8T641CH39F1003. Yeah, evidently. C8T6401542C10. And it's looking like the main circuit processor. We have a 8 megahertz crystal, I suppose. Okay, what else? Here we have a diode, obviously, and 74H24051D. These are multipliers. And this is a 084C MZ3V139. Okay, a transistor. That's I think that's for commanding the relay. Anything else? Okay, what is this? LB2K. 5 pins only, and that one is PFN1, also a 5-pin circuit. And this is DCO 138 Pro version 1.5. Oh, pretty young, I may say. That's the new connector I just soldered in the last video. And that's it. Okay, we got another circuit here, LB2K. Also 5 pins. That's it, guys. Not too much, but it's doing the job, you know. Okay, what I want to show you today. Okay, let me see if I can use the microscope for that. Can we go a little higher? I found something interesting. So, you see here, this is the plus from the battery. The plus, it's going down here somewhere. Okay, I have to find the connector. But anyway, if I'm connecting the plus to this diode here, and obviously to the plus of the capacitor, then we have power from the battery. And this is crazy nice. So I can say battery powered oscilloscope. Okay, so that's the battery. I had to reverse the terminals. They've been in another position, so that's why my connectors now are not exactly in place. Like I said before, I have to find a way to connect the battery plus here, from here, to these two diodes. I have the multimeter on continuity mode, and let's check. We have the plus here, of course, and I have to find the path. Where? Okay, so here we have a plus, and I have to connect this with this. A very simple connection will make this oscilloscope a battery powered. But remember what I said? This battery already have everything about charging and discharging on the battery, you know, on the board. There is a small board there. There we are. Okay, let me cut that. I'm sorry you didn't saw that. All right. So what I have done, I have a piece of wire from this to this one, and now if I connect the plus, the battery plus, with the capacitor plus, we're gonna have a continuity. That's the plus there, and there we are. Okay, of course, next step, let me insert the battery, and here we go. You got it? This is a powered oscilloscope, but there is a single something I have to find. If there is a charging current, and of course I'm gonna check the power now. Let's see over here. Let's see how much do we have on the battery, and we have 3.96 volts. And what is happening if I'm connecting a 5 volts power supply? Do we have any extra juice? 431. Yes, we have power here, and the BMS will take care about charging and protecting the battery. The power consumption, let's have a test about that, as long as we are here. Okay, let me take out the connection here. Okay, so here we are. Evidently no power, but the switch is on. I have to put my meter on amps, and we have 94.3 milliamps. Again, 94 milliamps. So around 100 milliamps. Let me have this back connected. Is it running? Of course it's running. Yes, people, everything is fine. All I have to do now is to find the position here, double tape on place. Okay, there's the connector there. I think that's the position. That will be the position of the battery. No, another try. Maybe like this. You know what's funny? There's not enough room for the battery. That sucks. I didn't realize. Yeah, I didn't realize that. Okay, maybe I can find some longer screws like that. No. Yeah. See something? Now I really don't care because I have plenty of place. Okay, maybe yes, like this. Oh, I need the other side. This is so perfect. Screws. Okay, there we are, people. The battery, it's nice there in place. Pretty okay. Double taped. You see? Of course, a little bit higher, but that doesn't hurt. And lights off, power on. Now we are absolutely independently about the power supply. Let's have a last test before using this mode. You know, it's a charging test. I have to be sure that the battery's got everything it needs to stop or to, you know, to finish the charging at the right voltage. And here I have my power bank, and there is my USB digital tester, you know, ammeter, voltmeter, and so on, capacity meter also, and that goes straight into FNIRSI 138 Pro. And as you can see, we have a current of 1.47 amps from the power bank to the battery. The test starts at 15:30, and let's see how long it takes until a proper finish of the charging. Yes, here we are 10 minutes later, still running good, 1.37 amps, 449 milliamps in the battery, no heat. It's looking very, very good. I like the way the current, it's pretty constant. I'm curious to see how much the battery should have this time, because it's not exactly an empty battery. But anyway, the point is that I want to check if the loading or the charging battery, you know, it's stopping at a certain voltage, and to be secure about all these things. And 15 minutes later, there we go, it's done. Okay, it's so pity we don't have a battery indicator here, so nothing on the screen, but we can do like this. We can have this on DC, 10 volts, 1X, and then if I'm touching the plus with the input, then we have a minimum value over there around 4.1 volts. So this is a way to check the battery voltage. Very simple, isn't that? Okay, I think it's useful, and if you think that it's interesting, oh, lights on. If you think that it's interesting, please like and of course subscribe, and don't forget, have fun. Bye bye.